In this set of videos, we're going to discuss case control studies, which are otherwise known as retrospective studies. This is the general case control design, where we begin with our target population, and from here we identify our cases and our controls. Those are people with the disease and those without. And then we look backward in time for the occurrence or exposure to the exposure of interest. So I always think of these studies as essentially the reverse of a cohort study. They still have a function of time, so they're not like a cross-sectional study in that they're not just looking at the outcome and the disease at the same time, but it's really just that they're looking in the opposite direction. And so the hallmark of a case control study design is that it begins with the cases and compares them to non-cases, which we often call controls. So we start here, we choose our cases, i.e. our diseased folks, our not diseased folks, and then we look backwards in time for an appropriate length of time to assess for whether or not these individuals had the exposure that we're interested in. Now, the case control design spawns from the case investigation, which is a useful epidemiological tool to develop a high level of suspicion. It's also useful to study a rare condition. It's useful to understand a condition and identify etiology or causes. And it's also useful to study unusual or what we call epidemiology odd cases. Now, case investigations, though, suffer from the fact that they don't include a control group. So the case control study does. And as I said, this is a study where we're comparing persons with a given disease to persons without a given disease with regard to their exposure status and certain background characteristics. And having the presence of an appropriately matched control, and I'll discuss matching in a bit, leads to the ability to draw inferential conclusions. And the case control study proceeds from effect to cause. Again, it's the opposite of a cohort design in attempting to identify antecedents that led to the disease of condition that's presently being observed. And so the objective of our case control study is to compare the odds of exposure among persons with the disease to the odds of exposure among persons without the disease. As with the cohort study and a cross-sectional study, the case control study must include a well-defined source population from which we collect our cases and our controls. And then there are lots of considerations in this design that we'll discuss, having to do with how well or how will we identify our cases and our controls, how do we define the disease that we're studying, and that the case identification should be as complete or thorough as possible within our source population, meaning the goal would be to collect or assess the status of everyone in our source population so that we do not miss any cases. From there, we would choose a sample of cases who would represent all cases. And then the sampling of controls in our case control study should be representative of the general population of people who could have the exposure, as well as among our controls, we need to ensure that we have an accurate way to detect for or measure for the exposure to the risk factor. And so what this is saying is that there must be a system or a method under which the controls can be assessed for having had the exposure or not, in the same way as the cases. And this can be performed in a variety of ways, such as interviewing the cases and the controls, medical record review if records exist for both, testing, etc. And then I just leave you with some questions. And these are the questions that we think about when we're designing a case control study. And most importantly, with a case control study, the selection of our cases and of our controls should be independent of the risk factor that we're studying. Ideally, we shouldn't know the risk factor status at the time we select our cases and our controls. But in some instances, all that data exist at the beginning. And so we have to, again, ensure we're not interpreting or looking at exposure data when we're choosing our cases and our controls. And then one other point that's worth mentioning is both our cases and our controls must have a non-zero probability of having had the exposure. And so what that means is we don't want to choose individuals for our case control study who could have never had the exposure that we're studying. Now, there are various types of case control studies. I'm going to go through the most common types. Clearly, there are a variety of case control designs out there in the literature and combinations of them, but I'm going to really focus in on the kind of the classical ones. So the first is a nested case control study, and the idea here is that we're performing a case control study within a cohort study. That's why it's called nested. And that cohort study could either be a prospective one or a retrospective one. And the beauty of a nested case control study is that the population is already well defined and followed longitudinally, such that we theoretically have all of the exposure information that we need up front, collected on all persons in that population. Now, it differs from a cohort study in that the exposure assessment is not performed in all members of the cohort, because we're going to select a sample of cases and a matched sample of controls in this cohort study, and we're going to look for their prior exposure. So again, we're not looking at exposure in every individual. But because all the exposure data have been collected in this design, it makes for a cleaner sort of case control study, and oftentimes we don't have the issue of missing data. Now, for each case in the nested case control, a control or a set of controls, for example, you could have more than one control for each case, is randomly selected from what's called a risk set. And that risk set it comprises the subjects in the cohort who are at risk at any time of having the disease or the diagnosis of each of the cases. So what we're doing is we're controlling for the confounding effect of time. So we're going to match each control to that case based on the length of time that case spent in that cohort study. And therefore, each matched pair will have the same length of observation time or at-risk time for having developed the disease. Because again, keep in mind, in a nested case control, we're dealing with data from a cohort study. So at one point, patients were studied who did not have the disease of interest. So lots of advantages of nested case controls. First of all, the cost is reduced because they're being performed under the auspices of a cohort. There's also the advantage that there's a reduction in what's called recall bias, and this is a bias that happens in case control studies whereby the cases or the controls differentially report their exposure status because of their current status of disease. Well, in a nested case control, you don't have recall bias because you've already collected your exposure information at baseline. So there's also better temporality with this design. And there's a reduction in selection bias, again, because the cases and the controls are selected from the same cohort. The next design is a case cohort study. This is where cases are cohort members who develop the disease, and controls are a random sample of members from that same cohort. Now, the difference here is we're not performing this study under a well-defined cohort study. And controls are selected without any matching on time or any other relevant variable to the cases. Those variables, such as time and other factors that may be potential confounders, are accounted for in the analytical, in the analysis of the results. Now, persons in the source population from which the cases and controls are polled must have the same chance of being selected as a control, regardless of the person time that they contributed to the study. Lots of advantages with a case cohort. There's a reduction of selection bias because the members are chosen from the same cohort, the same population. This is a more subtle point, but we can often obtain a valid estimate of a relative risk within a cohort, whether the disease is rare or not. And we'll get into this more in a bit, but generally in case control studies, we cannot measure relative risk. Another advantage is the use of external comparisons, where we compare the risk estimates in exposed group within the cohort with that of an external population. And with a case cohort, we can also study or examine multiple diseases, so we can have multiple case controls. The third type is the incidence density case control study, and really the aspect of this is that cases are sampled as they occur, and controls are matched to cases based on density sampling, such that the controls selected have the same exposure distribution as the cases, or they have the same person time in the study. So the probability of selecting any potential control subject is proportional to the amount of time that he or she contributes to the denominator of the rate.